be the primary instructor for this course. In the next 4 weeks, you will actually learn how to use Matlab to solve problems in mechanical engineering. All right, so Matlab is a widely popular programming language, so it's used a lot in industries and academic institutions all over the world. So in the first class, what we are going to be doing is we are going to give you an introduction to Matlab. And once you have the introduction, what you need to do is, you need to practice the sample programs that we'll be discussing today. After which, we have some exciting challenges for you in our leaderboard interface. Go over there and work on those challenges. And if you have any questions, get in touch with us. All right. So in order to follow along with this coursework, you need Matlab. And if you don't have Matlab, you can download it from their website. They have a 30-day free trial. Your academic institution may also provide you with a valid license of Matlab. All right. So before we jump ahead, let me explain to you the layout of Matlab. So this is how it looks like. This is the most general layout. And even if you are using version from 2015 or even 2014, it's going to look very similar to this. All right. So in the center, you have the editor window. So this is where you type your programs. All right. So for example, I can just open up some examples that I have. This is how I type the programs. And this right here is the command window. So the command window is like a calculator, or you can also think of it as a command line interface with which you can run programs in Matlab. You can navigate through your file systems and so on. So on the left, you have your current folder. So typically, you need to be in the folder where your programs are saved. So you can make sure that, you are in the right folder. Okay. In addition to this, you have your workspace. The idea of the workspace will be clear once we start typing a few programs. Okay, so that's basically it. So to get started, let's click on the command window and then start with some simple commands. So as I said before, the command line tool is like a calculator. So you can basically do arithmetic operations very easily. So when I do that, 5 plus 5, it says 10. And then the answers are stored in a variable called ANS. So ANS stands for answer. And you can see that in the workspace, you have a variable called ANS and the value is 10. Okay. Similarly, let's create a new variable, A equal to 20. All right. So when I say A equal to 20, you can see that is also added to the workspace. So the workspace is like a temporary storage where you can see the list of variables that are currently available in this particular session. So if I close Matlab and if I open it again, all of these variables would go missing. Okay, so let's do a little bit more calculations. So for example, I can say A times ANS. So the value for ANS is 10, A is 20, so 20 times 10 is going to be 200. And once that is calculated, that would be the new value for ANS. Okay, so if I hit enter, you can see that now ANS is 200. So in general, if you are not assigning a variable to an operation, then the default variable is chosen, which in this case is ANS. So for example, if I say B is equal to 50, and if I say C is equal to A times B, all right, you can see that C is now 1000. On the other hand, if I say ANS is equal to A star B, note that, or I don't even have to do this, I can just say A star B. You can see that the answer is set to 200 initially, but since I don't have a left-hand side, right? I just have the right-hand side, which is A star B. When I execute this, the value is getting replaced. Okay, so the command line, you can think of it as your calculator, right? You can do simple calculations, but not only simple calculations, you can do complex calculations as well. So for example, let us say I want to generate random numbers. I can generate, just type in the rand command, and that's going to give me a random number between 0 and 1. So each and every time I execute this, you can see that the number is different. By the way, what I'm doing is I'm hitting the up arrow. That's going to show me the most recent command. And when I execute it, each and every time it prints a different number. Okay, so now the command line is almost full. So let me type in CLC, which is clear command, and that's going to delete everything in the command window. All right, so the command window can do much more. So instead of just working on a single number, it can work on multiple numbers. And this is what you call as an array. So an array is basically a data structure which helps you store quantities that are of the same type. So what do I mean by that? So for example, you can create an array that stores the density of materials. I can call it as density array. And to create an array in Matlab, I need to start with square brackets and I can type in some density values. Again, I'm just making up these numbers. You can use any numbers you want. All right, I think that's decent enough. All right, so this is what is called as a density array. So when I refer to density array, I'm referring to all of these values. I'm not referring to a particular value. All right. On the other hand, if I basically say density of zinc is equal to 3000 or 4000, I'm just making that up. I don't know if this is right or not. This right here is a single variable because it contains only one value. On the other hand, this right here, a density array, it's an array because it contains multiple values that are of the same type. So when I say type, these are all integers. Okay. Now in Matlab, the definition of type is not very strict. So for example, you can have floating point numbers and integer numbers together. All right. But the general idea is you can think of array as a group of elements. All right. So if you understand that, that is sufficient. So now let me create an array called volume. Okay. And let us say the volume array contains 4 elements, 0.1, 0.2, 0.3, and 0.4. I'm keeping it simple. Okay. So if I know density and if I know my volume, I should be able to compute my mass, right? So density is mass by volume. So your mass is going to be density times volume. So what I can do is I can just say mass is equal to density times volume. All right. So when I do this, watch what happens. It's most likely going to give me an error, right? Oh, sorry. I think I gave the wrong variable name. It should be called as density array. Now the reason why I got this error is because we don't have a variable called density. So what is a variable? So everything on the workspace is a variable, right? So we have a variable called density underscore array. On the other hand, when I typed it, I just used density. So if I hit this, I'm going to get another error, which basically says inner matrix dimensions must agree. And this brings me to the next point where in Matlab, everything is a matrix. Okay. So what do I mean by that? So let me type in density array. So here, this is a matrix, which means you can think of this as 1 row and 4 columns. All right. And when I look at my volume array, that also contains 1 row and 4 matrix. So if you refer to your linear algebra, you will probably know that you cannot multiply these two matrices. Okay. So here what I want to do is, right, I want to basically multiply corresponding elements. So the first element in the density array, which is 1500, should get multiplied with 0.1. The second element, 1610, should get multiplied with 0.2 and so on, right? So that is very similar to dot product. So if you have two vectors and if you want to take the dot product, you need to multiply just the components. So the same thing can be achieved here by taking density array, and to do a dot product, you first type in dot, which is your full stop, followed by asterisk, which is multiplication sign, and type in volume. All right. So this is also called as element-wise operator. Element-wise operator is nothing but the dot operator, right? In which case you do element-wise or component-wise. So if I execute this, now I'm getting the value for mass. And since I don't have a left-hand side for this equation, right? So in this equation, I don't have a left-hand side. So the answer is getting assigned to the variable ANS. So I can go back and type mass is equal to density underscore array dot volume. And immediately you can see that the value is getting saved. And not only that, you can see that each and every time I execute a formula, the result is printed back in the command line interface. This is the default behavior. So what you can do is at the end, you can put in a semicolon. And when you do that, the output is not printed to the screen. It is still calculated. The only difference is that the output is not printed in the screen. Now, if you're coming from C or C++, you know that a semicolon is required at the end. Now in Matlab, the semicolon is used in a different way. It is used for only terminating the screen output. All right. So then what else can we do? From the command line window, let's make a plot. So what I'm going to do is I'm going to plot volume, and I'm going to plot, say, my mass values. All right. And let us plot it using a color, using the red color. And if I hit execute, I'm going to get a plot. So, the x-axis is my volume and y-axis is my mass. So why don't we just add x-axis, and I'm just going to call it volume, and not x-axis, x-label. X-label, I'm going to call this as volume, and y-label, I'm going to call it as mass. So when I do that, you can see that the labels appear. All right. And in addition to that, I'm going to just turn on the grid, and I'm going to get a pretty neat looking plot. I can save this plot, file save. I'm going to save it in desktop, and let us just call it as first plot. You can give it any name you want. And then let me save it as a PNG file. Okay, so we are saving it in the desktop, and if I navigate to my desktop, you can see that I have this particular plot there. Okay, so you can see that with Matlab, it's extremely easy to handle data, and it's extremely easy to make plots, do a data analysis, which is very much relevant to industries. In fact, in modern day industries, especially to get a job into an R&D company, having Matlab knowledge is extremely required. And I really hope that you're able to gain that knowledge from this particular course. All right, so now that we have typed some simple stuff here, let's actually look at the editor window. Now, the problem with the command window is if I close Matlab and if I open it again, all of the commands are gone because these are all temporary. They are not getting saved anywhere. All right, you can check that. For example, if you have practiced the commands till this point, close Matlab and reopen it again, you will see that all of your commands are gone. Okay, do it right now. So what I'm going to do is, I'm not going to do that. So I'm going to use the editor window. So the way you can create a new file is, just click on this new button. Now, if you're using an older version of Matlab, you might have to just use the shortcut Control N, or you might have a file menu, and then you can click on new file. All right, so you can see that I've clicked on it and then a new file opens. I already have a new file, so I'm going to close the one that I just now created. So this is like a text editor, it's like Notepad. You can type anything that you want, but it's meant for Matlab programs. So the idea behind editor is you can save the program and you can work on it anytime you want. So now what I'm going to do is I'm going to test out some commands. So testing some commands. Now remember that anything that starts with a percentage is a comment. Starting your program with comments is very good. So you can see that I've already been working with a few variables, right? And now I want to work on a new program. So I don't want to use these variables. So in other words, I want to clear my temporary memory. So I type the command clear all. So clear all is going to delete all the variables. In fact, watch what happens to the workspace variables. They get deleted, right? So that's what clear all does. And what close all does is it closes all the plots. So for example, here I can just have my plots side by side. And if I type close all in the command window, you can see that the plot goes away. So that's what close all does. And CLC is basically to clear the command window. So if I type in CLC, it just clears the command window. All right, so now that we have looked at these commands in the command window, let's complete our program. So we are going to type in the same program. So we are going to start with an array for density, and I'm just going to use another set of random values here. And for volume, let's just keep it simple as usual. And feel free to change the numbers, okay? And you can see that I've made a typo here. Now typos are really common, and you're going to make a lot of it. So especially when you're writing programs for the first time, you're going to make a lot of mistakes. The only way to deal with these mistakes is to be patient. Okay, so volume array, I'm just going to put a semicolon here. And mass is equal to density underscore array, and we need to make sure we do dot star volume array. Okay, so then you can click on this green button to run the program. The shortcut key is also F5, so I'm going to use the shortcut key. And when you do that, it is going to ask you to give a name to the program. So let me go to desktop, and I have a folder called temp programs. So this is where I save all of my temporary programs. And I'm just going to call this as first program. Okay. So when you name a program, make sure that you do not have space in the name. For example, first space program is not a valid name. Okay. So do not use any other special characters till you see me using it. So for now, just make sure that you use lowercase characters and just underscore is allowed. And the program is going to get saved with an extension .m. Okay, so I've saved the file, and immediately I get this prompt. It basically says that Matlab needs to navigate to that particular folder, which in this case is temp programs inside desktop, to to run this particular case. That's fine, because you can see here in your current folder, you are actually in d:\matlab 2017/bin, right? Whereas the program is saved in the desktop folder. So we need to navigate to the desktop folder in order for us to be able to run the program. So I'm going to click on change folder. So immediately you can see that I'm inside the temp programs folder, and the program is executed and I get the mass array. So now I can continue to work on this program, and let's just make the plot volume_array mass, and we can color the plot in green this time. All right, so now if I hit execute, you can see that the curve appears. Let's apply X label and Y label one more time. Okay, and then it works. So the advantage is, now that we have saved the program, it's stored in our hard disk. So I can shut down my computer, come back tomorrow and open this program, and I can start to work on it. Okay, so with that, I would like to conclude the first video, and make sure that you practice the commands and programs that we have typed up to this point. And that is the way we are going to practice in this particular course. We are going to give you videos, you need to practice them, and you need to make sure that you type in all the code, and also try to improvise, try to make some mistakes. Just based on what you have learned so far, you can actually work on some interesting problems from your textbook, try to solve it. Okay.